So at the end of the last video, I left off with a question about whether a quadratic or an exponential function was best to model this. Let me think. I might want to point out, show you a comparison side by side of the behavior of just a basic quadratic and exponential on the same screen. So I'm going to go back to my calculator, turn this on, and clear out my functions here and just add in a basic quadratic. So this would be x squared. And then a basic exponential, we'll use 2 to the x. And I want you to see these side by side. And so I'm going to go to my graph. And first I'm going to turn off that scatter plot. So as soon as I finish scatter plot, turn this off. Go back to my graph. And I'm going to change the window so that we can see a little bit more of this. So right now, the minimum value, I'm going to change this to 0. Actually, now let's change the minimum here to -10. And I'll change this to +10. We'll leave the scale at 1. And for the minimum, I'll just use -1. And then I'm going to go up to 100 with a scale of 10. Okay, so let's look now. So there's the quadratic. That's the graph of x squared. So we see this parabola shape. And then this is the exponential. So what I want to point out here is this exponential, first of all, to the left of the y-axis, it's actually, you can't see it in, the window here is very small, but it is actually getting closer and closer and closer to this x-axis. So it's increasing very slightly here, and then it starts to increase very rapidly. So that's the exponential. The parabola actually, is symmetric. So what's happening over here mirrors what's happening on the right-hand side. So it starts at a very high value and then comes down to 0. At some point, then it makes a turn and it comes up. Now, it does increase, but not as rapidly as the exponential. So when you're looking at a scatter plot and you're trying to decide between, you might consider, again, what's happening on the other side here. Is this a vertex? So a point to where the graph then changes and then starts to increase again. So that would look something like this, where it's the mirror image. Or is it decreasing here? So this would suggest that it's quadratic, and this would suggest that it's exponential. And we could also see, does it increase, if we don't have this information, is it increasing more like a quadratic, so quickly, but not quite as quickly as maybe an exponential might look more like this, where it increases a lot faster. That's what we're seeing here in the calculator. The exponential just gets bigger a lot faster. So there are mechanisms with data sets to measure the fit. That's beyond the scope of this class, but for now, I think that it's going to be enough sufficient to say, if you have the information, see what's happening on the other side of this point, if it continues to get smaller or if it makes a curve and gets bigger, and if you can, see which fits the data better, something that increases gradually or very quickly.